Welcome. Today we're going to be doing Law of Cosines. Now, if you have a triangle, ABC, not necessarily this particular triangle because they're all different, but ABC has sides of lowercase a, b, and c as shown. A squared, side A squared equals side B squared plus side C squared minus 2 times side B, side C, cosine of angle A. Please notice that whatever side you have here, the angle across from that side is what you're working with the cosine of. The other two sides are here and here. Don't forget the 2. Almost did that earlier. All right. And then it doesn't matter which side you're talking about or which angle, you can work out one of these three formulas. Remember, side, angle, and the side across from it is on the other side of the equal sign. It does look like a complicated formula. Don't let it overwhelm you. It really is not that difficult when you work with it. And we're going to try to find the sign, or the value of x in each of these problems. All right, let us start with this one. So we've got, let's see, we're kind of find x and we have the angle across from it. So x squared equals, I usually use the smallest numbers first, 13 squared plus 15 squared minus 2 times 13, 15, and then the cosine of 25 degrees. Even so we don't have the letters, we can just use the angle, the side across from it. Angle, side across from it. The other two sides. All right. Let's continue this. X squared equals, let's see, 169, 225. I multiply these together, and that's minus 390 times cosine of 25 degrees, 0.9063. Remember, you're going to round any cosine that you're calculating with to 4 decimal places, or any trig function to 4 decimal places. Now we'll continue with x squared equals. I'm going to first calculate this. And that's going to be 353.457. And then I will go ahead and add these and subtract these up. When I do so, I get 40.543. Now I have to square root both sides. X equals 6.4. Now we're going to be rounding these to 1 decimal place for our final answer only. The only other rounding is if you're using this, you're going to round to do the calculation. Outside of that, no rounding until the final answer. If you round too soon, you will end up with a different answer. Might not be a lot different, but that 4 might be a 5 or a 6 or a 3 or a 2. And that could significantly cause a problem for others. All right, let's go on to the next one. In this example, I have an angle. So it's the side across from it, 22 squared equals 25 squared plus 28 squared, the two sides, minus 2 times 25, 28 cosine of x. Let's look at our next little part here. 22 squared is 484. 25 squared is 625. And 28 squared is 784. Now Now I multiply this stuff up and it gives me 1400 cosine of x. One of the things people make a mistake with is they'll combine these two and this part, even so it's being multiplied times cosine of x. You can't add something that's being multiplied times something else first. You have to do the multiplication before you can do adding and subtracting in that combination. So what I need to do next is I need to combine these together. So 484 equals, let's see, I'm going to combine the 625 and the 784 to get 1409 minus 1400 cosine x. Let's see. I'm going to subtract 1409 for both sides, because I got to solve for cosine of x before I can solve for x. When I do the subtraction, I get negative 925 equals negative 1400 cosine of x. Now let's extend this a bit. Get rid of those little dots. I'm going to divide by negative 1400. And that will give me, let's see, 0.6607 14285 equals cosine of x. I write that whole display. Now, if it's already in your display, leave it in your display. So I've got my 925 divided by my 1400, and there's my 0.6607142285. Now I'm going to hit inverse cosine to find the angle. X is going to be, rounded to one decimal place, 48.6 degrees. There's my final answer in this problem. All right, let's look at when to use law of sines versus law of cosines. If you're given two angles and one side, law of sines. Two sides and the angle opposite one of the sides you're given, law of sines. If you're given three sides and no angles, law of cosines. If you're given two sides and their included angle, law of cosines. Now, let me just show you. This would be two sides and the included angle, because the angle is made up of those two sides. That was what it meant. That's what was meant by the included angle. All right, let's try solving the triangle with this situation. All right, I need a triangle first. So I'm just going to draw a general triangle. Not a particular one, so I'm just going to start filling things in. Let's say A is here, and that's 20. Let's say B is here, and that's 14, and C is 18. All right. So that puts angle A here, angle B here, and angle C here. It's helpful to draw a diagram so that you can visualize it, not just have to do it off the top of your head. So I always start with the biggest angle. And if I'm going to use law of cosines, I want to start with the biggest side, because the biggest angle is always crossed from the biggest side. Now, why does it matter whether I use the biggest angle or the smallest angle? Well, here's the reason. Let me just go to this. This is Desmos, and the red is sine, and the blue is cosine. Now, as we get to 95 and 85, those are going to have the same sine value. 95, let's see, this is yeah, this is 80. So 85 is somewhere around here, and 95 is somewhere around here. Those two values are going to be awfully close to each other. Whereas law of cosines, oh, sorry, I was looking at the wrong thing. There's 90. So 85 is here, 95 is here. And they're both positive. Whereas 90 is here. So this would be positive cosine, and this is negative cosine for 95. Sorry, I was looking at the wrong spot. 85 is positive with cosine, and 95 is negative with cosine. That way you're going to know whether you're working with 85 or 95 if they're close. Here, 85 is positive and so is 95, and they're going to have the same value. So you're not going to know which one is which. And that's why I always use the biggest angle first, biggest side, which is across from the biggest angle. So I'm going to work with angle A and side A. So let's see, 20 squared equals 14 squared plus 18 squared minus 2 times 14 times 18 cosine of angle A. That's where I'm starting. Now, if you're going to use law of cosines twice, which I'm going to do on this example, you could use law of sines, but I'm going to use law of cosines. Remember, one of the big things that's helpful here is that when you're working with these, you're going to be using the same numbers squared. So it's going to help you if you can keep track of those numbers. Like 400 equals 196 plus 324 minus, well, 2 times 14 times 18 is 504 cosine of angle A. Now let's combine like terms. Let's see, 520 minus 504 cosine of A. I'm going to subtract 520. So that gives me negative 120 equals negative 504 cosine of A. Then I'm going to divide by negative 504. I'm going to put cosine of A here so I can write out the decimal. All right. 0.23809. 538, I think. All right, there might be a 2 in there, but you'll see it on your display. Inverse cosine. And that's going to give me 76.2 degrees. So angle A, 76.2 degrees. Now I could use this with this side and now use law of sines to find, say, another angle. However, remember, this is a rounded answer, so instead of using that, I'm going to use law of cosines again. Now, it's up to you. You could use that, and it wouldn't be that much different. But I like to use law of cosines in this case. So let's find angle C, I think is next. Yes, angle C. 18 squared equals 14 squared plus 20 squared minus 2 times 14 times 20 cosine of C. Now, we just saw 18 squared was 324, 14 is 196, and 20 is 400. All right, so that should mean 324. I think that should be a different color. Let me do that. All right, 196, 400 minus, let's see, 560 cosine C. 596 minus 560 cosine C. Subtract 596. All right, that's going to be negative 272 equals negative 560 cosine C. Divide by negative 560. So that gives me 0.4857. 14285. And it turns out C, when you do inverse cosine, is 60.9. If you ever end up with an angle that is across from a side, and that angle does not end up being the biggest angle, but that side is the biggest side, you know you've made a mistake. I have two angles in my triangle. So if I add these up and subtract from 180, I'm going to get 42.9 as my final angle. So 60.9 is C, and 42.9 is B. Now, notice the smallest angle, smallest side, largest angle, largest side, and middle. That's what's supposed to happen. And there you have it. There's the process. Let me go back down to here. There's the process using law of cosines twice. You never have to use it 3 times because you'll always be able to find that third side another way. All right, last problem. Let's look at this example. Again, the two sides and their included angle. I could not possibly use law of sines here for this part. Let's do law of cosines and find side A. All right, there's my setup. Side A equals side C plus side B minus 2 times C times B times cosine of A, 46 degrees. Again, it doesn't matter which of these comes first, here or here, because of the commutative properties. A squared equals 121 plus 225 minus, let's see, what's that come out to? What's on the back side? 330. Cosine of 46 degrees, 0.6947. All right. Now, I need to multiply these two together. And that's going to give me 229.251. Now I combine all of this together, and it gives me 116.749. And then, of course, I have to take the square root to find A. A is 10.8. this side and this side are awfully close together. So we can anticipate angle C to be very close to angle A. Let's find that. Actually, we're going to find angle B first. So sine of 46 degrees over 11 equals sine of angle B over 15. Once you have all three sides, and an angle, you can now use law of sines. Now, sine of 46 degrees is 0.7193. At this point, we'll cross multiply. And when I cross multiply, I get 11. Sine of B equals, let's see, 10.7895. Now I'm going to divide by, wait, something's not right here. Why did I write that? Oh, duh, look what I did. I used side C instead of side A. Let me fix that. This should be 10.8. See how easy it is to make a mistake if you're trying to rush? 10.8. Take your time. Make sure you're putting in what sides you're working with. Angle A, side A. Angle B, side B. Okay, easy to make a mistake. 10.8 is what we're dividing by. Sine of B. Let's see, that came out to 0.9990. Well, these are almost the same number. They're very, very close. So B, angle B, is going to be 87.5 degrees. So I can say this is 87.5 degrees. Well, now I can use my subtract from 180, add them up and subtract from 180. 46 and 87.5 would be 133.5. And when I subtract, I get 46.5. Wow, 46.5, that's horrible. Let me fix that. 46.5 degrees. That is so close. It's only a half a degree different, and this is only 2/10 different. So that makes a lot of sense as to why they would be so close. All right, biggest angle, biggest side, smallest angle, smallest side, and the middle. Here is your homework for tonight, and that is it. Have a great day.